Hi everyone. In this video, we are going to be looking at the graphs of sine and cosine. So we'll start out by studying those graphs with our graphing calculator. And our first step here, our first step is to turn the calculator on. And usually when you turn it on, it will look like this. So I need to click y equals in order to enter a function. Now, if you look at the calculator, sine, cosine, and tangent, the trig functions are right here. Another important thing to check is that you're in radian mode because we only use radians. So the way that we do that is where the calculator says mode, we click on it, and we make sure that radian is highlighted. If it looked like this, degree would be highlighted. That's bad. So we want to have radian highlighted. Now let's look at the graph of sine of x. So what I do is I do sine and then my variable and make sure to close the parentheses. If I use the standard zoom, the graph looks okay, but not that great. There's a particular window that makes the graph of sine look good. So if we hit zoom and then 7 for trig, the graph is a little bit more readable. So you'll notice that this graph just looks like a wave. You've probably heard the term sine wave before, and the reason for that is because the graph looks like a wave. And if, let's say we want to graph this on our own, we can do so by looking at the table of values. So maybe I want to choose my own values here. So let's start the table at 0, and we'll go by increments of pi over 2. And we'll look at the table again. So what we know is that when we plug 0 in, we get 0 out. So 0, 0 is on the graph. I'm going in increments of pi over 2, so this is pi over 2. When I plug pi over 2 in, I get 1. So the point pi over 2 comma 1 is on my graph. At pi, I'm back down to 0. At 3 pi over 2, I'm at -1, excuse me. And at 2 pi, I'm back to 0. Then at this next increment, I'd be back up at 1. At 3 pi, I'm back down to 0, then back to 1. If I want to be a little bit more careful, I can make this go by, let's say, pi over 4. So if I look at the table now at 0, I'm at 0. At pi over 4, I'm at 0.7. At pi over 2, I'm at 1. At 3 pi over 2, I'm back down to 0.7. So we can put as many of these dots as we want and then just connect up the graph to look like our nice sine wave. You'll also notice in the graph that we have the same sine wave repeating on the left side of the axis, so I could continue this way as well. Okay, so let's make some observations about this graph. Notice that we have x-intercepts at every single multiple of pi. So I have an x-intercept at, for the x values, x equals 0, pi, 2 pi, 3 pi, 4 pi, and so on. I only have one y-intercept, and that's the origin. So it's at 0, 0. Now I want to observe something about the fact that this graph continues to repeat itself. This property of repeating itself is called periodic. So periodic basically means the graph repeats itself. Period is the amount of time to repeat. Or to complete a single cycle. So let's say we start here, then I go up, I go down, into negative numbers, I come up, and then I start repeating myself again. If I took this little section of graph and slid it on top of this section, they would line up. That's what I mean by repeating. Like you could take a section and just repeat that section over and over again. So this amount of time is the period, this space. So the period is the difference between 0 and 2 pi, so the period is 2 pi. Now there's another term that's related to a graph that looks like a wave, and that's amplitude. Amplitude is defined as half the distance between high point and low point. So if this is my high point, it occurs at -1, and this is my low point, it occurs at 1. The difference between these is 2, so the amplitude is just 1. Another way to think about amplitude is just the height of the wave. So now let's use these same ideas to study the graph of cosine of x. So I'm just going to turn off the graph of sine of x and put in cosine of x. So now we're looking at a new function. If you look at the graph of sine of x, the first wave started at 0, 0. For cosine, when x is 0, we're starting up here. So let's look at that table of values again, so we can plot our own version of cosine x. Okay, so in the table it says at 0, our y value for cosine is 1. At pi over 4, it's at 0.7. At pi over 2, it's at 0. At 3 pi over 4, it's at -0.7. At pi, it's at -1. Then we go back up to -0.7. 3 pi over 2, we're back to 0. Then we go up to 0.7. At 2 pi, we're back to 1. And notice that these values just start repeating after that, because cosine is also periodic. So now we can connect these up into our nice cosine wave. Oops. Like that, and it will keep going. It keeps going on this side as well. So if you notice here, my x-intercepts are at pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. So when x equals pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. And we could keep going where we'll have an odd number on top, a 2 on bottom, multiplied by pi. The y-intercept, instead of being at 0, 0 like sine, it's at 0, 1. So you might say one cycle of sine looks like this wave that starts out going up and then comes down and then goes back up. One cycle of cosine, we might say, looks like a tulip. It's sort of this shape. And then it starts repeating that tulip shape. But again, we take this tulip, we repeat it, starting at 2 pi. That's where we start repeating. So the period, again, is 2 pi. The amplitude is the height of our wave. So it goes from 0 to 1, which means the amplitude is 1. So for both of these functions, the period and amplitude were 1. So we'll study in class why these graphs look the way they do, but these are the important properties to understand about the basic graph of sine of x with no transformations and the basic graph of cosine x with no transformations. In the next couple of videos, we'll explore how we can change the period of the graph using transformations and how we can change the amplitude of the graph. And we'll also do our usual thing of shifting left and right. But this is our starting point. So make sure that you know these very well.